In this equation, if we're supposed to solve this, this is a quadratic, which means solving this is the same thing as being asked to find the x-intercepts. We just said a moment ago that in an x-intercept, the y-coordinate is always 0. It's always something, comma, 0. If that's the case, if y is supposed to be 0, then here's what we're going to do. In this equation, we are going to set this up so that y is 0. This is not going to change anything about how we do these. This is going to connect to something we saw last week. If we're finding an x-intercept, y has to be 0. So first thing, I'm going to rewrite this. Instead of y equals, I'm going to say 0 equals. The only thing that that does for me is now this is an equation I can actually solve. I only have one variable. We can't solve an equation for two different variables. One variable at a time. Y is 0. Now we can solve for x, the only variable that's left. To do this, though, we have to somehow simplify this whole process. And this is where our ability to factor something is going to come into play. X squared plus 8x plus 15 is in the form that we have already talked about. Ax squared plus bx plus c. So we have an a, a b, and a c here, which means we can set up the x method and factor this. And we're going to go ahead and do that right now. So please set that up on your paper. Remember, the top is a times c, the bottom is b, the left and right, our denominator is a. And we are going to find our two missing numbers. If we fill this in, a times c, that would be 1 times 15, which is 15. B is 8. Our denominator, a, is 1. I need someone to tell me, please, and raise your hand if you have an idea, what are the two numbers that I am missing? They will multiply to make 15, but if I added them, they make 8. This should be one of the more obvious ones that we look at. Multiply these two numbers to make 15. Add the same two numbers to make 8. Jalitha? 5 and 3. 5 times 3 gives me 15. 5 plus 3 gives me 8. So far, none of this is new. We did this last semester. Again, I'm going to go ahead and make my two binomials. I have 1x plus 5. And I have 1x plus 3. Here's where it becomes different. Here's where I need everyone's concentration and focus. This is leaving something out. This is leaving out what we wrote at the very beginning. This is supposed to equal 0. The only thing that's going to change is now it gives us a goal. Before it was just an expression. That times that. Now I have to find what number could I plug in for x that would make that times that equal 0. This is what I'm trying to find. To do this, you have to remember a certain fact about numbers that you all know. Every last one of you knows this. There's a name for it, but I'm not going to give you the name until after someone says it, because it makes it too obvious. I'm supposed to multiply two things. I hope everyone agrees. This parentheses right next to this parentheses means I'm multiplying them. Everyone agree?
Yes.
Okay. Answer this question for me, please. Raise your hand if you have an answer to this next question. What type of number do I need if I'm multiplying to make 0? How can I multiply and end up with something that equals 0? What type of number would I need to multiply two numbers and end up with an answer of 0? Taylor? Do they both have to be 0? Just one of them? Great. This is what is called the zero product property. Oops, I already wrote product. Property. Zero product property. There are only two properties I make you remember all year long. The first one you already know, the distributive property. This is the second one, zero product property. The zero product property simply states that anything times 0 equals 0. How many of you already knew that? Raise your hand. I told you. You all know this. This is not new. But here's what this allows us to do. If either one of these things is 0, the whole thing will be 0. So here's what we get to do. This is very, very similar to what we did last semester when we had absolute value equations. If I could make this parentheses equal 0, isn't 0 times who cares what this is gonna equal 0? What if I made this one equal 0? Do I even care what this is? No, because times 0 it will equal 0. So here's what we do. I am going to say x plus 5 equals 0. And right next to that, I'm also going to solve x plus 3 equals 0. Because, as we just said, if I can make this first thing, x plus 5, if I can make that equal 0, the whole thing will equal 0. If I can make the second one equal 0, the whole thing will equal 0. So we simply solve two separate, very, very short equations, in this case, one-step equations. We all know how to solve a one-step equation, so I'll just write it out quickly. Minus 5 on both sides. One of our possibilities is x equals negative 5. On this one, we'll subtract 3 on both sides. Our other possibility is that x equals negative 3. Those are our two solutions. When we solve a quadratic, how many solutions do we expect? 2. Very good. And here we have 2, negative 5 and negative 3. You could go back to the original equation up here. If you plug in a negative 5, you will get 0. You would get 25 minus 40 plus 15. That would equal 0. You could plug in a negative 3. You would get 9 minus 24 plus 15. That would also equal 0. If you graphed this parabola using an XY table, and then you looked at that parabola on the graph, your x-intercepts would be at negative 5 and at negative 3.